In this video, I am going to explain about the organic chemistry and first we'll see some basic concepts. So in this, first I'm going to explain about the hydrocarbons. So hydrocarbons, or organic compounds, they are same. Hydrocarbons or organic compounds, they are same. Hydro for hydrogen, carbons. So when the carbon hydrogen is present, then it is said to be organic compound. So organic compounds or hydrocarbons are the substances. They are the substances having carbon and hydrogen as essential elements. Carbon and hydrogen as essential elements means they cannot be found without carbon and hydrogen. Like we have seen in class 10th, benzene. Benzene is made up of carbon and hydrogen. C6H6 is the formula. But this is not all. And they may have some other elements. Other elements can be present like oxygen, nitrogen, sulfur, phosphorus, halogens, etc. So they are non-essential elements. We say them as non-essential elements. And carbon and hydrogen as essential elements means it is compulsory to have this, and they may or may not be present. Now something more about the organic compounds. There was a Swedish chemist, Berzelius. So Berzelius proposed a theory called vital force theory. And this theory, Berzelius explained that the formation of organic compounds is based on some forces, vital forces, and these forces are present in nature. So the substances, they are formed by some mysterious forces, and so he named vital. Without the vital forces, there cannot be any reaction or formation in living system, and so this is about the vital force theory. But later on, this theory was rejected. By the synthesis of organic compound from ammonium cyanate. This is ammonium cyanate. Ammonium cyanate aqueous solution. When it is heated, then there is formation of this is urea. This is found in all animals. Animals, urine, perspiration, it is having a smell, particular smell due to the decomposition of urea. So this is pure organic compound, and this ammonium cyanate, it is pure in organic compound. It is pure inorganic compound, and so this theory was rejected. Vital force theory was rejected. Actually, this was performed by Polar, and who explained that there is nothing like that of water force theory. And so this is the basic about the organic and inorganic compounds. Inorganic compounds, we say the compounds which are obtained from the earth crust. And so this is all about the brief introduction. Now other point of organic compounds is tetravalency. So tetravalency is made up of two. First is tetra. Tetra means four, and valency, the combining capacity. Combining capacity of an element is called as valency. You know about this. So by tetravalency we mean, or it is defined as the ability of a carbon atom, to attach itself with four neighboring atoms, other is four neighboring atoms, or by four bonds, four neighboring atoms or four bonds. Like if I draw here methane, this here we have this carbon is there, one carbon attached with four hydrogens. Similarly, if I write here this is methanol, this is methane. Actually, the tetravalency has been explained for carbon by going through its electronic configuration. See how. To explain the tetravalency, write down the electronic configuration. Carbon, say 6, 1s2, 2s2, and 2px1, 2py1. So this is the electronic configuration in the ground state. This is the ground state electronic configuration. Means the resting phase, resting state. Now here it appears to be divalent. Here it appears to be divalent because two half-filled orbitals are available. You have seen in chemical bonding that the participating orbitals must be half-filled, but here only two, so it appears to be divalent. But actually it undergoes excitation. So in excitation or during reaction, one electron from this goes to other. So it is like this: 1s2, 2s1, 2px1, 2py1, and 2pz1. So see here, four half-filled orbitals are available. So this is the tetravalency. These are four half-filled orbitals available, and so this explains the tetravalency. Now coming to next topic, it is catenation. So catenation, it is defined as the self-linking of atoms of only one kind. Self-linking means linking of atoms of only one kind is called as catenation. And so see this carbon, and if this carbon is attached like this here, this is called catenation. Only carbon atoms or atoms of only one type. The property of catenation is the feature of group 14 of the periodic table. All the members of group 14, they have tendency to exhibit the catenation and similar atoms. But the tendency of catenation is exhibited maximum by carbon and then less by silicon. Silicon also exhibits, and so it is group 14. And then there can be germanium, then much less by tin and lead. So maximum tendency for carbon and silicon. Why it is there? The catenation is due to 2 points: high electronegativity. High electronegativity means very strong tendency to gain the electrons, and second, a small size. So carbon has very small size, and same is the case with the silicon also. And so as a result of this, there is the tendency of catenation. And so what is the effect of catenation? So this is a very important point. Due to this very large number of organic compounds, very large number of organic compounds are there. There are millions of organic compounds. And why it is so? It is because of the ability of carbon to attach itself in a variety of manner. And so this is the point about the catenation. Now next is functional group. So you have seen in class 10th, functional group may be defined as an atom or group of atoms which are responsible for the properties of an organic compound. So it is defined as an atom. It can be one atom or group of atoms responsible for the properties of an organic compound. Properties means the physical as well as chemical. Like if we write X, so X is for the halides, and this X is halogen, and the compound will be RH. Similarly, if I write here OH, so here the compound will be alcohol, and it will be ROH. This is alcoholic group. Similarly, if I write here CHO, so it will be compound will be aldehyde and RCHO. If it is COOH, then it is carboxylic and RCOOH. So this is there. It is responsible for the physical and chemical properties of an organic compound, and so it can be an atom or group of atoms. Like if I write here this CHO, so carbon double bond, then COOH, C double bond. So this is about the functional group. Next is homologous series. Homo means same. It is made from Greek word, so homo means same. So homologous series means when the members of a particular family differ from each other by a definite margin. So when different members of an organic family, different members of an organic family differs from each other by a definite margin, differs from each other by a definite margin or constant margin. We have seen in previous class, and they differ from each other by CS2. You have seen hydrocarbons can be, alkanes, alkenes, alkynes. They're different. So here, if I write the alkane family, simplest member, it is methane, homologous CS4. Then second is ethane, C2S6. Third is propane, C3H8. Fourth is butane. Butane is C4S10. C4S10. Now they differ from each other by which margin? They differ from each other by which margin? They differ from each other by CS2. Here they differ from each other by CS2. They differ from each other by CS2. So this is there. So not only the alkanes, but alkenes also differ from each other by this constant margin. See how? Like, alkene family. So simplest alkene, it is ethene, C2S4, then propane, C3H6, then butane, C4H8, then pentane, C5S10. So they also differ from each other by CS2. Actually, the adjacent members, they differ from each other by CS2, and so they are called homologous of each other. So they are called as what? Homologue of each other. So irrespective of the group or family, alkanes, alkenes, alkynes, or any family, alcohols, carboxylic, all are said to be homologous of each other when they differ from each other by a constant margin. Similarly, we have alkynes also. Alkynes, ethyne, C2S2, then propine, just add C3S4, then butane, then C4H6, then pentane, C5H8. So the adjacent members differ from each other by CS2. And so this is there about the homologous series. Now we have to see about the nomenclature or naming. So organic compounds have two names. First is common name, and it is also called as trivial name, means in common language. Second is scientific IPA name. And so common names are not based on any scientific rules, regulations, while they are based on scientific rules. Like HCOOH, it is called as formic acid because in ancient times, Greece persons, they used to extract formic acid for medicinal purposes from ants, and so it is there. Similarly, here this CS3OH, it is called as wood spirit. It is found in a small amount in wet wood. So this is about the basic introduction of the organic chemistry.